Review Chapter 12, Circles. Okay, we started out this section, 12.1, with tangent lines, and the main idea here was that tangent line is perpendicular to a radius at the point of tangency. Okay, let's look at our first problem here. It says, assume that the lines that appear to be tangent are tangent and find the value of x. So in the first problem here, I see a quadrilateral. I see two radii in our circle here, and I see two tangent lines. That means I know that these are perpendicular, and I know that quadrilateral 90 plus 115 plus 90 plus x equals 360 degrees because it's a quadrilateral. So 295 plus x equals 360. I subtract 295 from both sides, and x equals 65 degrees. All right, that was an easy one to start with. Let's look at our next one here. I see a quadrilateral circumscribed about our circle. That means we have points of tangency, and our theorem there said that tangent lines that intersect outside of a circle are congruent. So let's look at this one. All right, that means that this and this are congruent. So I know from here to here measures 4, and this are going to be congruent. And so from here to here equals x. So x plus 4 equals 10. So x equals 6. Two really easy ones to start off with there. All right, the next problem, we are looking to find the length of our radii. So I know that this length here, I see a right triangle there, this length here is going to be x plus 7. This is also the hypotenuse of our right triangle. So I am going to use a squared plus b squared equals c squared. And that's going to give me x squared plus 10 squared equals, this side is the length, x plus 7. I am squaring that entire length. So I have a binomial squared here. So I can either remember that that's a special case and know what it comes out to be, or I can just expand out my binomial and square both sides, and then I'm going to distribute, which is going to give me x squared plus 7x plus 7x plus 49. Then I'm going to combine my like terms. X squared plus 100 equals x squared plus 14x there plus 49. And if I remembered my special case, I know that my middle term here is 2 times x times 7, which would have been 14x. Remember, if you remember your shortcuts, remember your rules, makes things easier. And I'm going to subtract x squared from both sides. And that gives me 100 equals 14x plus 49. And then I'm going to subtract 49 from both sides, just doing the opposite operations. And I get 51 equals 14x, divide both sides by 14. And x equals 3.642857, so we'll round to the nearest tenth, 3.6, So our radius is 3.6 centimeters. Don't forget your units. If you're given units, your answer will have units. All right, those first three weren't bad. Next problem, determine whether a tangent line is shown in each diagram. Well, what do we know? We know that if you are tangent, then you are perpendicular to the radius at the point of tangency. So we are looking at this point right here. Is it tangent? Well, how do we know if that's a right angle? If it is a right triangle, then it's a right angle. So we have the Pythagorean theorem. The hypotenuse is C. We are wondering if that is a right angle. And so this is a big question mark. So 9 squared plus 14 squared equals 17 squared. 81 plus 196 equals 289. And that is 277 equals 289. That is not true. So no, it is not a right angle, not perpendicular. Therefore, not tangent. All right, that was 12.1. 12.2 was chords and arcs. And these first ones, the first theorems in these said that our central angles, congruent central angles, have congruent, central angles are congruent, then your chords are congruent, and your arcs are congruent. And we also had the diameters and perpendicular bisectors of chords. Diameters, perpendicular bisectors of chords. Now we had some things that were necessary for that. There were 3 of those. It said if the diameter is perpendicular, then it bisects. If the diameter bisects, then it's perpendicular. And if it's a perpendicular bisector, then it's a diameter. So I'm going to look at my first problem here. And the first thing that I see is this diameter right there. Now we're only looking at part of it, but we know that the whole thing is there. It's a line. We're just looking at this segment. And so I can say that this is bisected because this diameter is perpendicular to the chord. So this piece is 4, this piece is 4. And I have a radius. How am I going to deal with this? Well, I am going to draw a radius right there. That is also measures x because all radii in a triangle are congruent. So I now have this right triangle. This measures 4, this measures 3.6, and I'm looking for the radius x. So once again, Pythagorean theorem equals c squared. This is my hypotenuse over here, so that's c. 3.6 squared plus 4 squared equals x squared. So 12.96 plus 16 equals x squared. X squared equals 28.96. And don't forget to square root both sides. Definitely not a perfect square, so we're just going to throw that one into our calculator. X, or our radius, equals 5.38145, so 5.4 rounded to the nearest tenth units. Not too bad. Okay, what's the next one? Well, we have this segment here that is perpendicular and bisector, so we know that this 2 right here is a diameter, and we are looking at this chord, and we have this other diameter that's 12, so our diameter is 12, so our radius equals 6, and I think I am going to draw in another radius that equals 6. So once again, I have this right triangle here. This measures 3, this measures x, there's 6. So one more time, Pythagorean theorem, b squared equals c squared. My hypotenuse is over here, so that's c. X squared plus 3 squared equals 6 squared. X squared plus 9 equals 36. Subtract 9 from both sides. X squared equals 27. One more time. Do not forget to square root both sides. Now, this I can tell is divisible by 9. So this would be square root of 9 times square root of 3. So we could say x equals 3 square root 3. Generally not a number we are going to be able to use, so we throw that into our calculator. 3 square root 3 is 5.196, so x is, round to the nearest tenth, 5.2 units long. So we could use that to find the entire length of our chord if we needed to. All right, that first page went pretty well. Let's see what's next. Ooh, 12.3 was inscribed angles, and we said that the measure of the angle is 1/2 of the measure of the intercepted arc. And then we had some corollaries that went along with that. Let's look at our first one here. We need to find the value of each variable. Assume that rays that appear to be tangent are tangent. Okay, so, well, we could do C first. We could find the measure. A is this arc right here. We could find the measure of that arc. It is part of an entire circle, so we know A plus 90 plus 150 equals 360 degrees for an entire circle. So we are going to subtract 240 from both sides. So A is 120 degrees. 20. Now, I see an inscribed angle. The vertex is on the circle, so I have this inscribed angle here, B, and I know this is the one that is a tangent. Don't let that confuse you, because that is still an inscribed angle. The vertex is on the circle, and so B is going to be 1/2 of the intercepted arc, which is just arc A here, so 1/2 of 120 degrees. B equals 60 degrees. So that was easy. And finally, we need to find the measure of C there, and I see an intercepted arc for C here, and we know that C is going to be 1/2 of the measure of the intercepted arc, so C is going to be 75 degrees. Not bad at all. All right, next problem. We need to find A is the measure of that arc, B is this little angle right here, and that's all we have. So how are we going to find the measure of this arc right here? Well, its endpoints are there. It is related to that angle, so I know that the measure of my arc is 2 times its inscribed angle, so 2 times 77. So A is going to be, what is that, 154 degrees. 154 degrees. All right, so this is 154 over here. how am I going to find B? Well, we have a couple of ways. One of them would be I see another inscribed angle right here that goes with this arc. So I know that the measure of that angle is 1/2 of its intercepted arc, which is 54 degrees. So that is 27 degrees. This guy over here is 27 degrees, and then I can use my triangle angle sum theorem and vertical angles. I know that B here is a vertical angle to right there, so that I know B plus 27 plus 77 equals 180 degrees. So I'm going to subtract 104 from each side, and I'm going to get B equals 76 degrees. B here, 76 degrees. Now, if you're looking at this, in 12.4, we did lines that intersect inside of a circle. So there would be my intersection, and we could use these two arcs. We could find these. We have a diameter, and this would be the 1/2 of the sum of those two arcs. But that's not what we're doing in 12.3. But hopefully you saw that and said, hey, I've seen that diagram. That's from, we'll do some more of those problems when we get to 12.4. Let's just focus on what we're doing right now. All right, next problem. Oh, we've got a lot of things going on here. First thing I see is an inscribed angle that intercepts a semicircle. That diameter should stand out. First thing we know is that B is a right angle. B is going to measure 90 degrees. So now let's look at A. Well, how are we going to find A? Well, we know that A is going to intercept this arc right here. We don't have the measure of that arc. But do we have another angle that intercepts this arc? Yes, we do. This one right here, our tangent one. So we know that the measure of this arc here is 2 times this angle that we're given, which is 43. So the measure of our arc is 86 degrees. So I can write 86 degrees out here. And then I can find A is going to be 1/2 of that intercepted arc, which is 1/2 of 86 degrees, which is 43 degrees. And if you notice, A equals 43 degrees. This was corollary 1. We have 2 arcs, this one right here and this one right here, that 2 inscribed angles that intercept the same arc, this arc right here. Now this isn't as obvious as on some of our other problems, but notice our angle measures are congruent. So if you can see things like that, we know that this and this are going to be congruent. Either way, we still figured it out. So A here is 43 degrees. And then you know how this works. A little triangle angle sum theorem says that 43 plus 90 plus C is going to equal 180. So this, we're going to subtract 133 from both sides, and C is going to be 47 degrees. which is all pretty reasonable. All right, last one in this section. I see a quadrilateral inscribed inside of a circle. Means we've got tangents, and this is another one of our corollaries, and it says that opposite angles are supplementary. So these should be really easy to do. So a plus 75 equals 180. Subtract 75 from both sides. A is 105 degrees. Put 105 here. B is going to be the same thing. B plus 80 equals 180. Subtract 80 from both sides. B is 100 degrees. Those were easy. Now, how am I going to find the measure of C? That's this arc right here. Well, if I look at this whole thing and go clear around, I know that it's related to this angle right here. So that entire arc, the measure of my arc, is going to be 2 times my angle, so that's 2 times 75 is 150 degrees. So this entire thing is 150 degrees. So I can say that C plus 30 is 150. Subtract 30 from both sides, and C is 120 degrees. So this piece here is 120 degrees. The entire thing is 150. All right, so 12.3 wasn't too bad either. This looks like might be a good place to pause, and we will do the next few sections, the last 2 sections, on the next video.